experience in analytics and machine learning, working primarily in financial services companies. Right now, I work in consulting, general strategy consulting, and I do this training on the weekends. Yeah. So I'll be your instructor for this class. Now, before I begin, right, I don't know you guys, right? So I will start with a round of introduction. Now, the way this introduction will go is, people who are joining me online, they will use the chat functionality to introduce themselves, and people who are here, you can speak, right? I need your name, what you are doing right now. If you're working, what are you working on, right? And I need, why did you decide to join this course, right? What do you want to get at the end of it? Clear? Okay, so I can start with you, ma'am. Yes. Mm-hmm.
There I'm working on tools, Power BI and Tableau.
Okay.
And sometimes I need to use Python
Yeah.
and R. So I know R. And I want to go further into data science. So I thought it would be better to join this class so that I can move on with machine learning.
Okay. Okay. Yes. Yes, sir.
So my name is Manish. Currently I'm studying economics, and like I want to make a career in data analysis.
Okay. So you're a fresher.
Yes, sir.
Okay. So what background are you from? Economics. Okay. Cool. Yes. Come in. Yes, ma'am. Mm-hmm. Okay. Okay. Okay.
This for data science with Python.
First class. Yeah. Okay. Cool. So where are you doing your PhD from? Okay. Nice. Nice. Yes, sir. Mm-hmm. 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 Okay. 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 Right. 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 Cool. Yes. Yes, sir. Introduction. You can sit.
My name is Shivam.
First class.
My name is Shivam Kumar, and I'm currently working in Bank
Mm-hmm.
as a data analyst.
Mm-hmm.
So it's been like around 3 years working over there.
Mm-hmm.
That's why right now I joined for data analyst.
Okay. Okay. Yes.
My name is Kushan, so I have work experience in UI.
Mm-hmm.
Currently working with another consulting firm doing IBM consulting. To explain something advanced and looking out for some advanced analytics course.
Right. Right. Okay.
I am working on R and for both in the last 2 years.
Mm-hmm.
And I have experience in Python for that studying.
Okay.
And I joined this course just because there are other predictive techniques, because I'm only working on time series and I'm working on neural net model.
Right.
So on that basis, I need to evolve some more techniques, just to explore and.
Okay. Okay. Got it.
So my name is Siddhartha Sona. Currently, I'm pursuing a teacher,
Mm-hmm.
and I want to make a career in data science. So that
Okay.
my name is Ronnie, and I'm currently working at Acxiom as a full stack developer. And I want to switch my career in AI.
Okay.
My name is Faisal, and currently I'm also working in Azure, it's a startup, and I'm working as a full stack developer over there. And I want to switch my career towards machine learning, and yeah, that's why I'm taking.
Okay.
Basically, I can work on SQL and this basically just wanted to
Right. Okay. Mm-hmm. Okay. Cool.
My name is Yasin, and I completed my family in the 18. I opt for this course because I am good with mathematics and statistics. So I want to start my career in data science.
Okay. Yes, sir.
My name is Jaspreet Singh. Currently, I'm not working because I have been training students on the IT technologies, mainly Cognos.
Okay.
I wanted to become like open source technology. Wanted to develop my skills in open source technology. That's why I opted for this.
Okay. Okay. Yes.
So hello everyone, my name is Ethan Amal and I'm currently working so I'm currently working on Excel, VB and SQL only. I'm just wanted to move to new technologies in my
Okay. Cool. So most of you guys, I understand, are experienced, right? 1-2 years of experience. There are a few freshers as well. Okay. Right. So how many of you have done any sort of programming before? Any sort of programming? Any? No, any programming, any sort of programming, C, C++, Basic, Visual Basic, GW Basic, Logo, any kind of program. Most of you did, right? Okay, that's good. That's make my job, that will make my job easy. Now, to begin with, so today's class will not go into the exact course, right? So today's class is more about introducing you to the system, as in how the logistics will work out, how will you join classes, where do you find recordings, how will you get the course materials, what we will cover during the course. So today is more or less about that. And then we will talk about what is analytics and what is a data scientist, what is the usual job of a data scientist, and so on, right? So today's class is basically about making yourself comfortable with what we are going to learn. Python. Yes, first class. Today is we are basically talking here about what we are going to learn during the next classes, right? Now, to begin with, couple of ground rules, right? Especially for people who are joining online. So people who are joining online, when you join, please be on mute. If you have any question, please unmute yourself, ask the question, and then be again on mute. Because each and every class will get recorded and it will be there for you to refer back later on, right? If people who are online are not on mute, what will happen is the recordings are going to get spoiled because there will be noises that will be coming, right? So people who are online, please maintain a sort of mute if you don't have anything to contribute. If you have any question, of course, please unmute yourself and ask the question. Is it clear for people who are online?
Yes.
Okay, cool.
Yes, sir.
Now, there is a chat functionality which is there for people who are online. I strictly encourage that if you have any question, please ask it verbally, because it gets difficult for me to look at the chat window continuously and keep track of the class as well. So if you have any question, please make sure that you unmute yourself and ask it verbally, right? Chat functionality will only be used if you want to show me any snippet of code and so on, right? If you have any question, ask verbally. Now, with the ground rules said, the typical class will be of a 3 hours duration, right? Within this 3 hours, I typically break down the class into 2 1.5 hour segments, and we have a 10-15 minutes break in between, right? So that's the usual flow of the class. Now, coming to the course of what we are going to cover here, all of you had gone through this list that I'm showing. Okay. Any questions on this list? Or what I'll do is I'll again go through this list, right? If you have any questions whatsoever regarding the course, please let me know. Yes, please come. Okay, whatsoever questions regarding anything, right? Because from now on, I'll be your point of contact with respect to everything, right? So if you have any questions, let me know. I'll go through this and then you can ask your questions. Okay. Now, the total course is going to be around 60 hours. 60 hours, 3 hours per class, that boils around down to around 20 classes, right? But the number of classes are not fixed. Fixed in the sense, we can extend the number of classes to more than 20. That doesn't matter, right? As long as we finish everything, we will take as many classes required. Okay. Usually we try to finish it by 24, 25 classes, right? Plus minus 1 or 2 depending upon the speed of your batch. Now, so the first thing that we are going to study, which is what we are going to do today, is we will introduce you to what is data science. So today we will talk about what is data science. I mean, we will bust some myths about what is data science, what is analytics, data warehousing, etc., etc. We will talk about what is the relevant skill sets that are required in the industry right now. We will talk about some of the leading companies which are working in this sector. And we will talk about what is the typical flow of a data science project. So this is what we are going to talk about today. Okay, so Arvind Kumar, can you hear me clearly now? Rest of the people who are online, can you hear me?
Yes.
Yes.
Yes, sir.
Yes.
Yes.
Yes, I'm able to hear you. Thank you.
Okay.
Yes, I can hear you.
Oh. Okay. Now, from the next day onwards, the first thing that we are going to do. So today it's all about introduction, right? From the next day onwards, the first thing that we are going to do is do the basics of Python, right? Now remember, this course is data science with Python, right? So it's not only about Python. Python is just a tool that we'll be using to deploy the machine learning or the data science algorithm, right? So we will only touch upon the concepts in Python which are required in data science. Now it might happen that we will not touch upon certain concepts just because they are not required, right? Python is a very vast language, right? It has several applications. One of the applications is data science. This course is mostly focused on that. So we will only cover things in Python which have something to do with data science and will not cover things which are not related. Okay. Now, having said that, the first thing that we will cover is the basic building blocks of Python, which is common across all programming languages, right? What are the data types, conditional statement, loops, etc., etc., right? So we will first cover the basic data structures and basic tools of Python. Then we will go into specific data manipulation modules or functions that are available in Python, which we use in data analysis, right? So we'll slowly start from basics of Python and then go into data manipulation aspect of Python. Now in data manipulation, we will talk about how you clean the data, how you visualize the data, and how you can shape the data so that you can actually use machine learning algorithms on it. Okay. So this basic of Python and the data cleansing, this takes me around 4 to 5 classes, right? So by the end of this 4 to 5 classes plus today's class, which is basically around 6 classes from now, we will be ready to start with basic statistics. By the end of the 6 classes, you will be ready enough to start on basic statistical concepts. Now, when we go on to basic statistics, the first thing that we are going to learn is how do you analyze the data using basic statistics. Then we will talk about advanced concepts like estimation, hypothesis testing. Okay. Now, once we are done with that, then we'll go into the machine learning algorithms. In machine learning algorithms, we will talk about primarily linear regression, logistic regression, segmentation, decision trees, random forest, boosting, and some other techniques, right? So this is the flow of the whole course. Any question? No questions? Okay. People who are online, any questions? All of you are absolutely clear. No questions about this course, right?
Andranil, I have one question here.
Yeah.
Would you start from installing the Python, because I don't have Python installed on my local PC?
Yeah, I will show you how to install Python.
All right. Okay. Thank you.
So yeah, I have a question.
Sorry.
I'm online. So it was meant to be a 78 hours course, right? 26 classes. Has it been
20, yeah, 25 plus minus 1 or 2 depending upon the pace. That's the usual length of the course.
so has it been reduced to 60 hours?
Sorry?
Has it been reduced to 60 hours lately?
Oh, no, 60 hours is just the approximate value. I'm telling you the actual. The actual is around 25 plus minus 2 classes.
Okay, thanks.
Sorry, you were saying? Yes, yes. So now let's come to assignments, right? There are 2 kinds of assignments that you will get during this course. One kind of assignment tests you on specific modules. Second kind of assignments are holistic, right? So as and when we complete different modules, say for example, once we complete the basics of Python, you will get an assignment which will test your knowledge only on basics of Python. Okay. Next, when we complete the data manipulation part, you will get an exercise or an assignment which will test you only on the data manipulation part, right? Then once we complete the basic statistics, you will get an assignment which will test you only on basic statistics, right? And this way you will be getting assignments periodically which test you on specific portions of the course. Now, once we have completed the course in the sense that we'll take around 20, 23, 24 classes to complete it, right? Then you will be given a list of 8 to 10 different capstone projects. Capstone projects are end-to-end projects. These are all data analysis, real life based projects, which you will have to complete from end to end. Right? So you will be tested here upon all the concepts that you have learned so far, right? So that's the end goal. So we are planning to equip you so that you can independently work on these capstone projects. Now, if you are able to finish those capstone projects, you will have an experience which is equivalent to 1.5 years to 2 years of working in the industry. People who actually work in the industry for 1.5 to 2 years would have worked on that many projects with that different variety. Okay, so the case studies usually come from retail, HR analytics, banking, marketing, I think that's about it. Yeah. So the usually, yeah, one case study is also there on medical. Okay, so we have a wide variety of industries that will be covered in during the case studies. Okay. Now the usual way that we cover different modules is again using case studies. So what we will do is we will take one data set, understand the underlying business context, and then use Python and analytics technique to solve a business problem. So the class structure will also be centered around different business case studies, and obviously your capstone projects will also be case studies. Clear? Okay.
Excuse me, sir. I have one question.
Yes.
Starting 5 classes will cover like till this Python data analysis visualization.
Yes. I mean, again, 5 to 6 classes is the usual pace, but if you guys take more, less, that's totally upon you. There is no hard and fast rule that you have to finish this by 5 classes.
Okay.
I
Okay.
just
So I'm
told you
understanding.
what usually
I'm
happens.
sorry. So starting 5 classes approx cover like introduction to data science, Python introduction essentials, data manipulation cleansing, and data analysis visualization, right?
Yes.
Got you. Thank you.
Okay. Yes. Any other questions? Uh-huh. Yeah. Okay. So this module assumes that you don't have any idea about programming and you don't have any idea about statistics. So we will assume that, right? And then we will build up from there. So you should not have any problem. But having said that, again, I mean, I see the place where people struggle is they don't have time to dedicate during the weekdays, which you will have to manage, right? You will have to dedicate some time during the weekdays also, because if you just come to the class, after a point of time, you will not remember things enough, right? And then you start to fall back. How do we provide placement assistance? Now, placement assistance is provided you have completed all the modules and assignments. Now once you have completed everything, the way we provide placement assistance is through referral. So we go to a lot of corporates for corporate trainings, and if there are any requirements, we usually refer the students to those companies, right? So that's how the resume preparation will be done again post you have completed all the assignments, but there is no mock interview that happens. But what I tend to do is, after a point of time, once we have covered basic statistics, at the beginning of every class, I tend to ask questions which usually are asked during interviews. So you will get a hang of questions which you expect. Yes. Anything else?
Yeah, hello. So one question.
This is the.
There are other
Mhm. Right. Yes. This is the scope of the current course that you have joined. Okay. What algorithms do you have? Do you have anything in mind that you want to cover specifically? I can then upfront tell you whether that's possible or not. Oh, okay. If you're talking about specific deep learning applications, right? This is not the course for it. There is a separate course which specifically focuses on deep learning, right? This is everything that is prior to deep learning. KNN will be covered, not ANN. ANN will cover basic, but not different architectures. We'll cover the vanilla artificial neural network. Okay, so if you have any questions related to assignments, right? So if you get stuck in any assignments are something which you have to do independently, right? If you get stuck in any assignment, the only place that you can seek help is Google. Okay, Google it, right? And you have to build that habit of finding out solutions from Google, because that's how you will be doing in your real life as well, right? So Google it. If you then also can't find a solution, then obviously we can discuss it in the class. For the capstone project, Google. Yes. Google is the primary help source. If you can't find solution in Google, which I don't think will happen, then we can discuss it in class.
Sir, I have a question.
Yes.
Yeah. So, in this course, which softwares and tools would we be using?
The only software that is used in this course is Python. That's
Okay,
it. And,
that's it.
and Excel, I guess all of you will have.
Okay, nothing. I mean, nothing new.
No other software.
Okay. Thank you.
Okay. Anything else? Any other questions?
Sir, I had a question.
Yes. Sentiment analysis will be covered. Okay, it's not here. Huh? It's not here. Sorry, that's my bad. This is a bit dated. So it might be that couple of points I have missed in. Yes, we will cover sentiment analysis. Yes, after this, I mean, sentiment analysis should have been here, but it's not here. We'll cover. No, we will cover sentiment analysis.
So Ashish Agarwal this side. Actually, I have gone through EDX course, Data Science Essentials. So there I
have been going through what?
EDX course, Data Science Essentials.
What is EDX?
EDX.org is a website like who is going to provide multiple
online learning. Okay.
So actually, and I found there like Azure machine learning tool and worked on that as well. So here, like which kind of tool we are going to use?
We are only going to use Python.
With Python tool.
Yes.
Okay. Fine.
Okay. What about topics which are not cleared in class? Topics which are not cleared in class, ask me in the next class. Okay. I mean, we'll have to solve it either during the class or stay back after the class, come before the class. I'm usually available. So yeah, we can take it up.
Sir, if we miss a class and we are watching a video later, recording of that later,
yes.
How can we ask the questions?
Yes, ask it next day.
Okay.
Or I'll show you the other way also. I'll show you there's one more functionality which you can use. I'll show that to you as well. But the best thing is to ask it the next day.
Okay.
Is anything else? I will come to that. I'll come to that. Okay. Anything else?
Hello.
Okay. Cool. So this is all about the course structure. Now let's talk about the logistics. All of you have access to the LMS?
Yes, sir.
Yes.
Okay. If you don't have access to LMS, please reach out to your counselor or the person who you are in touch with and get your access, right? Because this is very important. Now, when you come to LMS, you will have a login and a password. If you log in, you will get a page like this, right? Now, in my current courses, since I'm not pursuing any current course, it's empty, right? So for you, it will be populated, right? And you will see something like, okay. Okay, I had a couple of courses here. Okay. Just give me a second. I think the internet is slow. Does any of you have access to this? You have access? Can I use your
Yes.
access? My access doesn't seem to work. Yeah, I'll not save it. Can you just log in here? Sorry to bother you. Yeah. Thank you.
Hello, sir. This is Prashant this side. Hello.
Okay. Okay.
Hello.
I have other questions
That's
as
fine.
well,
That's
because
fine.
I was previous student.
Okay, that's fine. Okay. Now, if you log in, you will have a course like this, right? And if you go into the view classes, you will have the recordings of the previous class in this particular page. In the previous class recordings, you have all the recordings, right? Just below each class's recording will be a Dropbox link. If you click on the Dropbox link, the respective materials that were used in this class will be present in that link. Okay, so the recordings will be here. Just below the recordings will be a Dropbox link. Go to that Dropbox link, you will get all the materials. Okay, now if you want to join your classes online, you will get the links in the upcoming classes. The Zoom meeting links will be here in the upcoming classes section. Okay. Now, if you have any questions during the class and you due to some reason can't wait for the next class, you have this discussion forum here. Go to this discussion forum, and within this discussion forum, you will see that there is a thread corresponding to your batch. Okay, go to that thread and then go to this topics, and within this topics, you can raise your own questions. Okay, you can actually write down your question, and this question will be posted to me and to all the people in this organization, and we will try to get back to you. Clear? Okay. Again, this class schedule is also here, which you can see when the classes are scheduled. Clear? Any questions on LMS? No questions? Okay. Now, yes. Assignments will also be present in that Dropbox link. All the assignments will be present as part of the class materials. Okay, so any questions till now? Yes, after completing the assignments, you will get a Dropbox link where you have to upload.
In the Dropbox, tools links
Yeah,
as well as the assignments.
One second. If you can't come to the class, all of you have the option to attend it online. Yes, sorry, what was the question from online?
Sir, like in Dropbox, you said all the tools links will be there as well as the assignments that we need to do. All things, right?
Everything will be there in the Dropbox link. All the materials, all the assignments will be there in the Dropbox link.
Okay, fine, sir.
Okay. Again, Pradeep, I would encourage you to please ask the questions verbally. Now, what about we are facing issues using? Okay, yeah, if you face any issue installing Anaconda, please bring your laptop to the class. We can sort it out.
Okay, sir.
Yeah. Any other questions?
Hello.
Yeah, the assignments, once you submit them, are getting evaluated. If there are any problems that we would want you to rectify, you will get an email. If there is no response, which means everything was okay. Feedback means if there are any yeah. So if there is no communication, which means that it's as per the requirement. Oh, right now, since you are just starting out with Python, we will not look at how you can optimize your code. If you can do a particular job and your code does that, it's fine. Right? Optimization can be done later on. Oh, you will have to learn it on your own, how to optimize the code. Optimization is not something that we will work on here. We are just, because you will see that it doesn't make sense to work on that in analytics. If your code does the required thing, then you are fine. Yeah. Yeah, the laptop configuration, I mean, okay, a traditional 8 GB RAM laptop should be fine. You don't need a very highly configured laptop. Is there any case study related to supply chain and procurement? There are no case study related specifically to supply chain, but if you have anything in mind, we can discuss that in class.
Okay.
Okay, anything else? Insurance sector, again, no. But again, if you have something in mind, we can discuss. Yes, we specifically have something in banking. Who will verify the assignments? There are people who verify the assignment. I don't do it, yeah, but there are people who do that. Cool.
Any end-to-end project on healthcare side?
Yes, there is one project on healthcare, which is a capstone project.
Okay.
I have a question here, generic question. Like I have a 10 years of experience in IT sector, but I'm working as a test lead. So at what level, how much experience level will I be counted after I complete this course if I want to switch my career into data science, which is completely different from the work I've been doing right now?
Right. It's a subjective question, right? It actually depends on you. Clearing an interview depends on how you can sell yourself, right? If you can justify your 10 years of experience, say for example, there was a particular person X who was working in testing, right? But while working in testing, the process that he did, there was some bit of analysis which that person was doing, right? Now, if that person can justify that analysis and reframe that analysis in a way which looks to an interviewer that he has done some sort of analytics, right? Then the whole experience can be counted, right?
Okay.
But if you cannot justify, then at least you will be counted as a 2 years experience.
Okay. Okay. Thank you.
Yes. Anything else?
Sir, Ashish Agarwal this side. So till 5-6 classes, I guess like there will be completely 2 assignments that we need to cover.
Yes.
To complete, right? Okay. And the third assignment will be from statistics.
The third one will be on statistics.
Fine, sir. Thank you.
Hello, one more question. I think last one from my end. Will you provide a gist of end-to-end project which will be there for healthcare? I might be needing that before it comes to, I mean, you are actually providing that. Will it be possible to get that?
Sure. I mean, I can provide that in another couple of classes. I usually give the list much before. I won't be inclined to do it today, but in a couple of classes for sure.
Okay, thank you.
Anything else?
I have one more question here. So
Yeah.
I have opted for a combo course here. So like, how much, what would be the duration of this project work? Because I need to attend the AI classes after that as well.
Yeah, it depends on you, right? It depends on how much time you will take. There are I think there are eight capstone projects which you have to complete.
Okay.
If you can dedicate full time on these projects, you can complete it within a week. It again, if you can't work full time, it depends on you. Okay, it totally depends on you how much time you take to complete it.
All right. Yeah. Okay.
See, for each of the assignments, there will not be any deadline, right? We will give you assignment, and we understand that most of you might be working, so we will not give any deadlines, but try to complete them as soon as possible, because otherwise they will keep on accumulating. Yes. Anything else?
Okay. When you say the full time, how much time you are saying here, like in per day?
5 to 6 hours a day.
5 to 6 hours a day. Okay.
Sir, accumulating means?
Accumulating means if you don't complete the first assignment, I give you the second assignment, then you have 2 assignments to complete.
Fine, sir.
And we have to finish all the 8 capstone projects?
Yes.
Or, okay.
Yes. Sorry, yeah,
it's a mandate, you are saying.
Yeah, because they don't know you are asking a question. They can't hear.
Assignment has been done by different people. So it may help in optimization.
You want to know how each person is doing it? That depends on you guys. So you usually, typically what people do is they create their own WhatsApp group and they share their codes within that group. There is no infrastructure that we will provide to share the code, but offline, obviously, you guys can share the code. Mm-hmm. There is no feedback that happens right now for Python. Yes. Any questions? Anything else? No, right? Okay. Cool. So this is the description of what I just told you, right? You can attend the classroom online, and in the class, everything will be recorded in LMS for you to access later on. You will have to complete the modules and the projects. We will evaluate the final project, and then you will get the certification and the placement assistance. Right? This is how the process works. No questions? You have any question? Okay. So these are some housekeeping rules. Go through it if you don't know already. For people who are not doing big data, this doesn't make sense. There are a couple of people who might be doing big data together with this. For them, this is the point. Done? Okay. Cool. All of you know how to access the LMS. If you don't, this is the link. You will get this PDF today. You can access the LMS. After you complete the course, then we will provide you the career assistance. Go through this. I'm not going to go through this. You can go through this later on. Cool. Any questions? No questions? All of you are clear on what we are going to cover?
So this document which you are showing, I have not.
Yes. You will get it. You will get it. So along with the recording for this class, the documents will also be provided.
And I don't see any study materials as of now on the LMS.
We will provide everything today. At the end, along with today's recordings, you will get everything.
Okay.
Now, so let's start with the introduction to data science, right? All of you are here to learn data science. And most of you want to either upskill yourself in data science or to change tracks into data science, right? Now, given the time and the demand in the industry, this is the right time, right? Because you see there are a lot of openings in data science, and this is probably the best time to switch careers into the hardcore machine learning and data science, because if you don't, you will become obsolete, because most of the things are now slowly moving towards machine learning. Now, what do we mean by data science, right? Or what do we mean by analytics? Any idea? All of you have heard about these terms, right? That's why you are here. So what is your understanding of data science and analytics? To make decision?
Yeah, so study of data and
not about decisions.
Study of data and to like to conclude on the specific results on the specific data. It's called data science.
Sorry?
To conclude, like to analyze the data and to conclude upon the specific result on that data is called data science. We can say.
Okay.
Yeah.
Those data to what exactly result you want, you can't find out those kind of data. But you need data scientists who can give you the insight that in those things decisions in the market, or you can generate more revenue as likely to get some money. I mean, data is a new one.
Mukesh Ambani did not say that. He quoted somebody else, yeah.
The most of the part that we have, the 60% part we have done is data analytics, that we found out what exactly what product we want to launch, what product we should launch. And right here you can see it affects 5% or so of my engine. That is really shows what's important.
Okay, so what is that shows how important it is, but what is data science? Okay, let me give you an example, right? Let's say you're working for a big retail company, let's say Walmart, right? Also heard about Walmart. Let's say Big Bazaar, right? Now, Big Bazaar has got some data, and they have calculated that on an average there are 3 cars
predicting the data so as to grow the business.
Sorry?
Predicting the data so as to grow their business.
Yeah, okay. I'm just giving you an example, right? Tell me whether that's data science or not. So Big Bazaar has found out that on an average, on a typical day, there are 3 cars that are parked outside their stores. Okay. Now, they have gone through a lot of data to get it, right? They went to all these stores, captured how many cars are standing, and etc. Is this data science?
No.
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 In this many months or in this many weeks or in this particular day, the our sale is of this type, so they can analyze that this is the seasonal, and this is the season where 3 bikes can be sold out.
No. Big Bazaar does not sell bikes, right? I'm saying there are 3. They have analyzed that there are 3 cars which are usually parked outside their stores. No, they collected, right? And they calculated the average. So they analyzed the data, right?
until unless there is no gain.
Exactly. So what does Big Bazaar has to do with how many cars parked outside? Right? They don't get any business advantage out of it, right?
Right.
So, yeah, but that they can directly track. So if you go to a Big Bazaar, there will be a person standing with a clicker just outside, right? They don't have to look at the car to know how many people have come in. They know exactly how many people came in.
So I guess there should not be any concern of the
I mean,
cars.
if you
Anybody
know
can
the
park.
of now the people that came in, what do you do with the number of cars? That doesn't matter, right?
Right.
Exactly. So number of cars doesn't give any meaningful information from the perspective of a retail company, right? I mean, if you are a car garage, maybe yes, right? But from a retail company perspective, no additional benefit, right? So data analysis is not about only getting insights from data, but getting insights which have any business impact or which are actionable, right? So it's data and science or analytics, which are, terms which are used interchangeably. This is a science, or you can call it an art of getting insights which are actionable for the business. Data science does not take action. It only can give you insights. You as a strategy manager have to decide what action to take. Say for example, one data insight from any retail company can be the average spend by a customer, right? That's an insight. Now, what strategy you devise using that insight is not data science. That is strategy, right? The job of a data scientist is to come up with insights which you can action upon. Now you can counter my logic by saying that if I don't know what kind of strategies are there, how can I come up with an insight, right? If you don't know what kind of strategies can be designed, you will not be able to know which is a relevant insight and which is not. That's where the domain experience come in. So in data science, what is also important is you have domain experience. So that's why if you are just starting your career in data science, you can switch between different domains. You can work for 1 year in a retail company, then go to a bank and work there as well. But as you move up the ladder, right, then domain experience become more and more important, because at that point of time, you have to get or take the call of deciding which is a relevant insight and which is not. Okay. So a data science or a data scientist is a person who gains insights through using data through computation, statistics, and visualization. These are three tools that you have at your exposure. Clear? Yes. Yes. Oh, you will have to, I mean, the software will throw you number in a particular format. You as a data scientist should be able to interpret the number in a way that a layman can understand. So you see, if you look at any job opening of a data scientist, you will see one of the lines there which says that being able to interpret complex concepts in a very lucid way. That's one of the skills that you will have to have, because the mathematics or the mathematical concepts that you will be learning here are quite advanced, and not all of the people will understand. And even if they do understand, they are not interested in the jargon, right? So you'll have to be able to write or explain things in a very lucid way. Yeah, that's why visualization is used, because visualization is universal. Here, so this is data science, right? Now, data science as a vertical, it's not exactly a field, but rather it's a process. Now, when can a company or an organization become successful in data science? You need to have a combination of three things. You need to be able to have a lot of data, because there is no if there is no data, there is no data science, right? The first requirement is data. then you have to have the expertise, right? That's where people like us come in, people like us, you will come in, where you will have the expertise to actually do something with that data, right? And then you have to have the culture. Now, what do I mean by culture? Culture basically reflects the attitude of the management. Now, often what happens is the management are, think about it, the person who is at a managerial level, he or she will be very experienced, and he or she will be very set in doing things in his or her own way, right? And data science is a very new field. Not all of the managerial people are comfortable in using data, right? Because they have been doing business using their own gut. How people used to do business before data science, right? Using their own gut and logic and experience, right? So most of the organizations, especially the big organizations, they don't have the culture to use data. What they'll do is they'll employ a data scientist, and they'll make that data scientist sit in some back room, and he'll keep on crunching numbers which nobody looks at, right? And that happens. So in order for a company to become very successful in deploying data science, you will have to have that culture where you actually base your decisions on data. And more companies are doing it in an increasing way, right? People nowadays, for example, if you look at, all of you use Netflix, right? Most of the Netflix produced serials or series, they use data science to figure out the exact content, right? Previously, if you what used to happen is people used to come with hardbound scripts of a particular program, right? Now what they do is they come out with hardbound scripts of probably 5 episodes, and then the rest of it is written online depending upon the feedback of the people. So everybody from industry to media is using data science to take decisions, right? In more and more ways. Okay. Now I'll tell you one interesting project which I had worked on. I was working with a company with Mercedes, or if you heard about Mercedes, right? The car company. So they were coming up with the advertisement for Mercedes SLA, the high-end sports coupe that they have. So they used data analysis to figure out for what amount of time should they show the Mercedes logo, so that has the maximum effect. So if you look at any Mercedes ad, you will see that it doesn't show only the car. It shows you a nice location, it shows you a nice road, it will show you the car, it will then show you the logo, it will show you it will even show you the sound the car makes, right? All of that build into that experience, right? They used analytics to figure out how long should the logo of Mercedes be shown, so that it has the maximum effect on the customers, right? The second example is there is a series in Netflix by Kevin Spacey. I forgot the name of the series. Yes, House of Cards, right? House of Cards script was written basis the public sentiment analysis. So they did a sentiment analysis when everyone was saying that this particular series will not work. They went based only on what people said that they wanted to see, and they designed the script around it, and the series was phenomenally successful, right? So data analysis is now more and more being used, right? These are two examples from media, right? You take another example from a car manufacturer. All of you have heard about Tesla cars, right? Tesla cars, there was a flood in California a couple of years back. What the cars did was, typically the cars, say for example, on a full charge, they'll go probably 100, 200 kilometers, right? Or 100 miles, I don't know. What the cars did was they automatically increased their capacity by pushing the battery, so that people who were on half charge could go out of the flood region. So the cars took decisions on their own to do that, right? Another example of what Tesla cars do is, if you are driving a Tesla car and if you see a pothole, right? the car will note down that the pothole is there and it will inform all the cars. So the next time when a Tesla car goes through that region, it will absorb the pothole in a very smooth way. The shock absorbers will adjust themselves, right? So this is all related to data, right? You analyze the data and then you can do magic with it, right? Another example is if you go to Amazon, right? When you log into Amazon and if you buy anything, what is the first thing that you see below? Recommended products, right? How do they know? And you will see that the products that they recommend are very relevant, right? Say for example, if you buy a mobile phone, they'll probably recommend a mobile cover, right? If you buy a washing machine, they'll recommend a washing machine cover, right? If you buy a t-shirt, they'll probably recommend a trouser. Now, how do they know? Is there a person who is sitting there and looking at the browsing history? No, it's only based on data. What they have done is they have analyzed what people usually tend to buy together. And then basis that they recommend products. The same thing happens in Netflix. If you go to Netflix, if you look at any particular movie, you will see the recommendations will show you similar movies if you like that movie, right? Another example is if you log into Facebook, right? Now, if you log into Facebook and if you upload any picture, you will see that it will suggest friends who are on that picture. How do that software know who are in that picture? Basis the data. What it has done is it has analyzed all the profile pictures of your friends and it will look for their faces in every photo that you will upload. And it will probably suggest their names, right? So everything today is basis data, right? And more companies are slowly focusing more on this aspect because you can, with data, you can basically come up with services which are micro level. So previously the strategy used to have, all of you have heard about the 80-20 rule, right? Pareto, right? 80-20 rule means you only consider 80% of the customer base, 20% will sort themselves. 20% you leave it to God. I mean, let them sort themselves out, right? Nowadays, each and every customer matters, right? So you look at the data to customize your service at a micro level so that each customer gets a different experience and an experience which is customized for him or her, right? So that's why the data science is very important, right? That's why we guys are in such a demand because more and more companies want to do that, right? And they don't have enough skills to do that.
Sir, one question is there. If we are going to find, like, let's suppose shoes there on any, like, let's suppose on Myntra, and we are going to close the application again, we are going to open it. Sometimes it's going to be reflect shoes like in a advertisement, and again if you're going to open Facebook, it shows again shoes in a like recommendation. So is that the work of cookies, or like what exactly the scenario behind
that is cookies.
Cookies, no? Okay,
that is purely cookies. Yeah,
fine, sir.
For example, okay. 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 Yeah. Got it. So if you do not have data with you, there are two ways to go about it. A, you buy data from your competitors, which most of the companies do. B, you get it from an open source case. Say for example, there are a lot of projects which are going on driverless cars, right? How do you train an algorithm to drive a car automatically? You need a lot of data as in dash cam data, right? Where a car is being driven. There are a lot of free source websites which will give you that data for free, and you can build your own algorithm.
Sir, is there any difference between data science and machine learning?
Yes. I will tell you a couple of websites which are really good for data, and there you will get a lot of data. I'll tell you.
Hello.
Yes.
Sir, is there any difference between data science and machine learning? Or both
Yes,
are same?
I will come to that. I'll come to that. Okay.
Sure.
Any questions on this page? Yes, I'll come to that. Yeah, I'll come to that. Any questions on this?
Sorry, in between there is expertise. So what kind of expertization exactly?
What kind of expertise? Expertise, okay, I'll explain what kind of expertise. That's also coming. Yes, anything else? Anything else in this page?
Sir, for data science, we need a past data mainly.
Yes, data usually refers to past data, right? You will not have future data for sure. So it's usually past data.
It is not live data or current data. Sometimes
It can, see, when you say live is also past, right?
Okay.
Live means what? Last second's data, right? That is also past.
Okay.
You cannot have data right now. I mean, by the time you record it, it has become past.
Correct. Yes, sir.
Okay. Cool. Now let's deal with some of the terminologies which are usually used in data science. What are the terminology that you guys have heard? Data science, analytics, BI, machine learning, and
Data scientist.
data engineering. Okay.
Data engineering.
Data mining.
Data cleansing. Manipulation.
BI is business intelligence. Data mining, that's about it, right?
Data visualization.
So there is two terms: business analytics and business analysis.
Deep learning.
Okay. That's about it, right? Okay.
Deep learning are also there, sir.
Data slicing.
And AI also.
Okay. Now, let me group them up into relevant brackets. Okay. So these are relevant names or names which can be interchangeably used. Data science, analytics, business intelligence are same, and there is no difference. It depends on which company you go to. They'll have their own terminologies to define it, right? Certain companies call themselves business analytics companies. Certain companies call themselves data science companies. These are, terms and terminologies which are designed more or less by marketing people who want to come up with things new every couple of years, right? I mean, we were selling data analytics in 2010-11. After a couple of years, they got bored with the term. They came up with data science. But that's a new thing, right? Let's sell this. Then they came up with business intelligence. Even before data analytics, there used to be business intelligence, right? So all of these are similar. All of this stand for analyzing the data to come up with relevant insights. That's it, right? Data visualization is a tool which is used to do that, right? It's not exactly a full field on its own, but it's a subfield where you only use visualization to explain or to communicate the insights.
So visualization is a tool.
Yes, sorry.
So data visualization is a tool.
Data visualization is not a tool, but it's rather a sub-field of data analysis where you use only graphs and visualizations to communicate your ideas.
I
So
think
if we
I
talk
think
about the definition of visualization.
Sorry?
So if we talk about the definition of visualization.
Definition of visualization.
I think it's a technique for the visualize for the data, sir.
Yeah, I mean, definition of visualization is communicate something using some sort of visualization, right? Either you use a graph or you use some sort of animation or you use some sort of infographic to communicate an idea.
Communicate an idea. Okay.
Charts.
Fine, sir.
Yeah.
Okay. Is this clear? This portion? Okay, I take it
Yes,
as
sir.
clear, right? Okay, now the next part, right? Machine learning, deep learning, and AI. These are applications of, these are again subfield of data analysis. Machine learning is so if I can represent this in a visualization kind of way, my drawing is really bad. So let's say this is a large circle, which is AI, right? This is AI. Now, what do we mean by AI? AI stands for artificial intelligence, right? This is the science of building machines which are intelligent. Now, some rudimentary examples are your microwave. When your microwave finishes heating up your food, it will beep. So it is intelligent enough to let you know that I am done, right? When your washing machine finishes washing clothes, it will beep, right? Or a fire alarm. It will beep, or an alarm clock in your mobile, it will beep, right? These are all some sort of AI which can communicate with you the outcome, right? Now, within AI, there is a subfield called machine learning. Now, this subfield or the believers in this subfield, they believe that artificial intelligence cannot be achieved only through coding, right? You cannot code artificial intelligence or a high artificial intelligent machine using just coding, right? You need a lot of data, right? You need to use a lot of data in order to build a highly intelligent machine. So machine learning is a combination of computer science and data analysis, which combines these two skills to give machines some sort of advanced intelligence, right? And our course is primarily geared or designed around this concept, right? So this is computer science plus data. Yes, I mean, when you say machine will learn themselves, machine will not, I mean, one fine morning stand up and let's say learn, right? You will have to program it to learn, right? So you will have to program using computer science and enable the machine to learn through data.
So can we say AI is the real world for the machine?
AI is the
real world for the machines.
What do you mean by real world?
Like where the machines will be work and learn about how to do the things and perform by using data.
No, AI doesn't always have to be like, you know, Terminator movies, right? AI can be very simple, right?
Okay.
I mean, all your every device has some sort of AI, right? For example, the AC, it switches off once the desired temperature is reached. That is AI, right?
Okay.
The machine is intelligent enough to switch off.
Okay.
Now, this is rudimentary AI. Now you talk about advanced AI like a car driving itself, right?
Yes.
That is advanced AI, or both of them are AI, but depending upon what is the application, you want some rudimentary AI or you want advanced AI.
Okay. Sir.
Totally depends upon the application.
Okay, sir.
Now AI can be achieved. I mean, the people who believe or invented machine learning, they believe that AI can be achieved. The advanced AI can be achieved using both computer science and data. You program a machine to learn through data and then enable the machine to take decisions. Okay. Now, within machine learning, around 2000. Yes.
Sensors are the example of artificial intelligence, right? Sensors.
Which one?
Sensors. Sensors.
Sensors are not artificial intelligence, but what you do with the sensor is artificial intelligence, right? Say, for example, AC, right? There is a sensor which can detect the temperature of the room. Now, using that temperature, you will communicate something or you will do something. That is intelligence.
And alarm of the mobile is not a artificial intelligence, right?
Alarm of the mobile is artificial intelligence, right? Because it communicates to you that a particular time has reached.
Okay.
Okay. Now, within machine learning, around 2004 or 5, there was a guy called Geoffrey Hinton who came up with a good way to train models known as neural networks, right? Deep learning is specifically a subfield of machine learning which talks about using a particular technique called neural network to solve a lot of AI related problems. So AI is the larger parent. Within that, machine learning is a subfield. Within machine learning, deep learning is a subfield which talks about or deals with only one technique called neural network. Now you might ask, why do we need something like a different branch to use one technique? The reason is neural network, although it's a single technique, the applications are very wide. If you are interested, you can search on the internet. There are a lot of applications of that network. How you can use a neural network can be very different from each other. For example, there is a neural network called CNN, or convolutional neural network, which is only used for analyzing pictures. There is a network called recurrent neural network, which is usually used to analyze things like language or sound, right? Although the underlying technique is similar, but since their applications are so wide, they had to come up with a different branch to deal with this network. Okay, so these are the three terminologies which people usually use when they talk about data slicing or data analytics or data science. Now, let's talk about data slicing and data mining, right? Data slicing basically means subsetting the data, right? Or slicing and dicing of the data, right? Data mining also basically means the same thing. You mine the data. Mine basically means you slice the data into smaller relevant parts so that you can analyze them, right? So that's data slicing and data mining. It is part of data manipulation. Data engineering and data warehouse have nothing to do with analytics. Data engineering and data warehouse is all about providing the infrastructure to store the data and to analyze the data. It's more of computer science and a database architecture and less of actual analysis of data. Right? So data engineering and data warehousing is all about providing the infrastructure for the data scientists to analyze the data. So a person who is working on data warehousing, his or her only concentration or his or her prerogative will be to optimally organize the data so that a person who wants to analyze the data can do it quickly. Right? And data engineering is also about that. You engineer the data in such a way that it can be analyzed very quickly. Okay.
So what is the difference between slicing and the mining in the data?
Oh, they're very similar, right? Mining basically means slicing and dicing. Slicing also means the same thing. These are different names. I mean, you can call them as synonyms.
Okay, sir.
Okay.
Sir, you mean that this AI, ML, and DL are a part of data science? They are the data science?
Yes. So AI as a whole is not part of data science, but the machine learning is part of data science.
It is just part of data science, right?
Yes.
It is like a not whole data science. So there is a difference between data science and machine learning. I mean that. Like for example, what I learned somewhere that suppose I'm using linear regression model, right? So I can do linear regression model in a data science also and in a machine learning also. So I was
These are not, these are not watertight bodies, right? Nobody has written down what is data science and what is machine learning. There is no clear distinction between them, right? Data science is everything that you do with data. Machine learning is typically, this term is used to refer to predictive models, which is part of data.
Only for predictive model, but data science like linear regression models are, so we also use this for predictive modeling, right? And ML is also we use for predictive modeling.
Right, because linear regression, because machine learning is a subset of data science, right?
It is subset of data science. Okay.
Yes.
Okay. So like, what is the difference? Why when we are using the linear regression model in data science and when we are using linear regression model in the ML? So what is different between both?
There's no difference. I mean, these are all marketing terminologies which have been invented. There's nobody told you that you cannot use neural networks as data science.
But sir, I know our
and call it as data science. Nobody will say that you are wrong.
But sir, I know our programming when I was using
Sorry?
I know R programming. I do data science R programming. So when I do linear regression model in the data science, so the way we build a model in different way, but in machine learning it is a different way of working. I was a bit confused that why it is going on and on.
What do you mean by the way you build the model was different?
So miss, when data science, like people told it is more manual method and
no,
more automated method. So I was a bit confused there. So that's why I want, because
you are wrong, right? I mean, linear regression is machine learning as well as data science, because machine learning is a subset of data science.
Okay, so means in machine learning also and data science we use statistics there.
Yes.
Right?
Yes.
Okay. Okay, fine. I will just do more research and then get back to you.
Yeah. You were saying something. Yes. So data cleaning is like data visualization. Data cleaning is also a subpart of data science. Yes, it's in the first group. So you will have to clean the data in order to analyze it, right? So it's a subpart of data science.
No. So data science is a process and business intelligence is a field, we can say, or what?
All of these are processes.
BI is again a process. Okay.
Yes.
Okay.
We'll come to that. Yes. Any other questions on this?
Business intelligence, a difference mean between business intelligence and artificial intelligence?
No.
Main difference.
Artificial intelligence is again the broad field. If you look at this, right, business intelligence is usually just analyzing the data and coming up with insights. You do not usually predict anything in business intelligence. Whereas machine learning, which is a subfield of AI, is usually talking about predictive.
Okay. So in business intelligence, we not talk about the business insights. That's what you were saying?
Yes.
So like what exactly we are doing in business intelligence?
We'll talk about this. During the course, you will understand what we will do.
Okay. Fine, sir.
Some category like mobiles, then they will show the mobiles and accessories. But within them the data has been prepared like they have been categorized among the mobiles and all. Like all those accessories which belong to mobiles, they have been categorized within mobiles. Like that, they prepare the data. So is this so? This is data science, right? For example, if I am searching for mobiles,
you are searching for mobiles,
and they are showing me the recommendation. They are showing me the covers.
Right.
So if I talk about the base data that they prepare, then they will categorize all these things in one category.
Yes.
Like mobile.
Yes. Yes.
That's how they prepare.
Yes.
So, but how? So we can't term it as machine learning.
It is, right? In mobiles and accessories, I mean, for mobiles and mobile covers, it is very simple. Say, for example, if you go to Myntra and you buy a white t-shirt, it will show you a white pant. Yes, but how it's not categorized as a white t-shirt, right? It is categorized as a t-shirt. Data science will tell that a white t-shirt goes well with a white pant. I'm just saying, right? It might not go well, but I'm just saying, right? So you can manually categorize it as a category, but you exactly don't know which goes with what. That comes out of data. Mm-hmm. Yeah, for mobile it becomes simple because the options are less. But if you go to clothes and apparels, then actually the data science becomes more evident. What intelligence? What is emotion intelligence?
Support of BJP, then you will find out the videos in support of the. Once you are negative point of the BJP, then you will find out the negative videos.
But that depends on what you are searching, right? Okay, so how do they know that you are opposed to BJP? Not that I'm saying you are, but no, it depends on what you have browsed before, right? If you have browsed, say, anti some party videos, I'm also giving an example. So if you have browsed, your browsing history shows that you are anti a particular school of thought, then it will show you that anti videos. That has nothing to do with data science. It's all about what you have seen before. It will show you the same thing. Okay. Right. So anything else on these terminologies? Cool. So let's do this. So let's take a 15 minutes break now, and when we are back, we will talk about rest of the concepts that we have covered today. Okay. So we'll start around 3:45. Now, now we all know what is a data science by now, right? What is data science? We are all more or less clear, right? And if you are still not clear, you will get more and more clear as we go ahead with the course. Now let's understand who are we aiming to be, or who is a data scientist. All of you are here to either make yourself a data scientist or move into data science, right? Now, who is a data scientist? A data scientist is a person who has three kinds of skills. A is computer science. By computer science, we typically mean programming skills, right? B is statistical skills, and C is domain knowledge, right? Now, if you're just starting your career, you obviously will have no domain knowledge, right? But as you grow in your career, domain knowledge become more and more important, right? And relevant as well. Now, data science is a combination. So if you see, a data science is basically a combination of computer science, statistics, and domain knowledge. A typical way of, I mean, if somebody asks you who is a data scientist, often people as a joke say that a data scientist is a guy who knows more statistics than a programmer and more programming than a statistician. So you are that particular guy who knows both programming and as well as statistics in a way which is well enough to be deployed, right? So you don't have to be a statistician or know every statistical algorithm by heart. Also, you don't have to be Mark Zuckerberg. You don't have to be really geeky and good enough in programming. If you build a basic knowledge of programming, that will do, right? So a data scientist is basically a mixture of a person who knows who is a statistician, a programmer, artist as well as a storyteller. So if you work in any data science project or any analytics project, you will hear of this word storyline, or what is the story of this project, right? So at the end of the day, a data science project is all about building a very compelling story with data, right? Because the business, I mean, see, who is your end client? Your end client is a business, right? Now he or she who is in a business, they don't care what technique you used. They don't care what software you used, right? They don't care what statistical jargon you can use. Only thing that they care about is what is your end story, right? What is your interpretation? So in order to be very successful in data science, you'll have to be a good storyteller, right? You'll have to have that skill to come up with very compelling stories out of data. Right now, how does a data science project look like, or how does this storytelling happen, right? A data science project starts with an interesting question. Now, what is an interesting question? Say, for example, you are working for a business and says the CEO comes up to you and asks you one fine morning that my sales are going down. Tell me why, right? That's a business question, right? Now, often this business question comes from the business. Often you are the one who will have to frame the business question, right? Say, for example, the business, I mean, the CEO might come to you and tell you that, okay, my business is not doing so good, right? Now, business might not do good due to a lot of reasons. It might not be good because the sales are going down. It might not be good because the profitability is low. Although the sale is high, the profit that you make per sale is low, right? You then will have to come to that question of what is the exact question that needs to be answered, right? My business is not doing well is a very general statement, right? It might happen due to n number of causes. You often as a data scientist might have to coach the business to actually figure out what is the exact business question, right? That often happens, right? And often the business is aware enough to actually tell you the question. Okay, so your analysis starts with a question. Now, once you have that question, you as a data scientist will obviously need the next thing, which is data, right? How will you answer the question? Using data, right? So what you do is you go to all possible data sources and you get as much data as possible, right? Because to begin with, you don't know which data point will be important, right? So as to start with, you go to all the data sources possible and get as much data as possible. So you see, in any data science project, 30 to 40% of the time is just to spend to understand what data sources are there and what data can we get from it, right? Because whatever story you are building depends only on the data. Your story is as good as the data, right? So if you do not do the getting of the data step very, very good, or if you don't get all possible data sources and all possible data, your story will not be as good as it could have been, right? So if you are writing a story, data is that ink, right? You are writing the story with data, right? If you don't have ink, you will not be able to write the story no matter how good a storyteller you are, right? So after you have asked the question, or if you have got the question, the next step is to get the data, right? Now, once you have got the data, getting the data also involves cleaning up the data, right? So when you get the data, typically the way you will get the data is it is in several places, right? Say, for example, especially if you're working with a large client, you will see that they'll have data stored in hundreds of tables, right? And each of those tables will have different stakeholders, right? Say, for example, if you are working for a bank, you will have to deal with people who are from the risk department, people who are from the marketing department, people who are from the sales department, right? They'll have their own data sets. Yeah, you understand, right? Each of them, it's a big organization, so each of them will have their own data set, right? But you as a data scientist need to have all the data. So you will have to manage all these people and manage all these data sources and bring all this data together into a single source of truth. Because analysis cannot happen on multiple tables. You at a time can only analyze a single table, or imagine a single sheet of Excel. If I give you data in, all of you have used Excel, right? Okay. Is there anybody who has not used Excel before? No, right? Okay. So if you see an Excel workbook, it has number of sheets, right? If I give you data in different sheets, will you be able to analyze them until and unless you get them together in a single sheet? Not at a single go, right? You can only analyze a single sheet at a single point of time. So similarly, in analytics also, you can only analyze one source at a time. So when you have multiple sources, a majority of the effort is spent to get all of this data into a single source. That takes around 30 to 40% of the time of any given data analysis project. Now, once you have got that sorted, the next thing is to ensure that the data that you are getting is correct. Now, correctness can be of two types. You have to eliminate typological errors, right? There might be typological errors, right? Like, oh, there might be missing data, right? Data which was missed inadvertently. Somebody did not enter their age. You don't have the data for it, right? So you'll have to take care of typological error. You'll have to take care of missing values. Also, you'll have to take care of abnormal values, right? For example, let's say you are analyzing data of a retail customer and there is one customer who is of age 120, right? That is not your typical customer, right? And if you use that customer, he or she will skew your whole data. Skew, you understand, right? If you calculate an average age, if you have a person who has an age of 120, he will pull up the average. Yeah. Or say, for example, you have a person like Warren Buffett coming to your store. He has income in billions, right? That one guy can pull up the average income of all the customers, right? So these are abnormal people. Like, I mean, they are not abnormal, but these are abnormal data points, right? Yeah, abnormal data points, abnormal transactions, right? So you will have to get rid of them, right? All of this come under me creating or cleaning a data, right? So you clean the data and create a very clean data, right? So you start with a question, you get the data in one single source, and then you clean the data, right? Once you have cleaned the data, the next step is basically to analyze or explore the data, right? Here in this particular step, you will use things like statistics and visualization to summarize the data. Now, say for example, you are working with a big Walmart, a client like Walmart, right? He will give you, or that client will give you a data which has 1 million rows. You have cleaned it up and everything is spick and span. You still have 1 million rows to deal with, right? So humanly, it's not possible for any human being to understand 1 million rows of data, right? So you have to summarize it or somehow visualize it so that the insights become very evident. How can you get insights? I mean, unless you are, you're somebody out of beautiful mind, you will not be able to analyze all those numbers, right? Humanly, it's not possible. So you will have to summarize the data, right? That's what is known as exploration of data. Now, summarization can happen in number of ways. Either you can plot a very nice looking graph, or you can calculate a number of statistics, and we'll discuss what kind of statistics you can calculate, which will summarize the data on their own. Okay. Now, once you have summarized the data, then you basically use that summarization to get a good understanding of the data, right? That's how you build your domain experience. If you keep on understanding data from a particular industry, over a period of time, you will build your own domain experience, right? Say, for example, if you look at retail data for 5 years, you will become a retail expert, right? You will then be able to take business decisions on your own because you know the data better than the business people. So That's what exploration of data is all about. Exploration of data is all about looking at the data and summarizing it so that you can become familiar with it, right? Now, once you have familiarized yourself with the data, the next step is to build something which is predictive, or which is known as modeling the data. Now, what is modeling the data? Say, for example, you want to figure out which customers out of 1 million customers that you have will be interested in a particular product. You have come up with a particular product and you want to know which customers to target, right? For that, you have to build an algorithm which will tell you which customer is more probable to buy that particular product. That is known as modeling the data, right? Modeling the data is to come up with those algorithms that can generate or help you do business better, right? Okay. Now, once you have modeled the data, now modeling the data is very technical. It's not something that everybody will understand, right? And not everybody will be interested in knowing those modeling techniques that you have used, right? So you will then, once you have modeled the data, you will then have to build a very, very lucid way of communicating the results, right? So let's say you have used some advanced methodology and you have built an algorithm which is really accurate, right? But if you cannot sell that algorithm to the business, what good are you, right? You spend 1 month, build a very good algorithm which is accurate enough. If the business does not get sold on it, your algorithm will be remaining with you, right? It does not get used anywhere, right? So that's why the last step is to actually communicate the results through either visualizations or through any other means possible. Okay, so this is the whole flow of data analysis, and every project of data analysis will go through each of these steps, right? Now, are these steps unidirectional? No. What might happen is, after you have asked the question, you get the data, right? And after getting the data, you realize that, oh, I have asked the wrong question. The question should be reframed. So you can always go back to the previous step, right? So it's a bi-directional flow. It's not unidirectional, right? And usually in a typical project, it will be bi-directional, because as you analyze data, you realize more and more facts. And then you can, you can either say, for example, in the exploration of the data step, you realize, okay, I need more data. I don't have enough data. So you again go back and get more data. Or during exploration, you figured out that the question that I've asked is not valid at all. So then you again go back and reframe the question. Okay, so this is the typical flow in which a data scientist will usually work. Any questions?
Sir, when you say modeling, data modeling, what is meaning of modeling, sir?
Sorry?
So once we say the data model, so what is meaning of data modeling, right? I have a data, and what is modeling?
Yes, you will understand data modeling when we talk about modeling, right? For now, you can think of modeling as building some algorithm. What algorithm, you will understand better when you actually work on it.
Sure, thanks.
So what are the other formats for the data except in the Excel CSV mode?
Sorry?
What are the other format for the data we can getting the data in the mode CSV mode except the Excel file? What are the other formats?
What do you mean by format? Why did I talk about format?
No, sir. I was asking that what are the other formats of data except the Excel?
Oh, except Excel, there is text TXT, there is CSV, there is Oracle database, there is Hadoop. I mean, there are n number of formats.
Okay, and so you are using the term data cleaning. What are the? Could you please brief that?
I explained, right? A data cleaning is basically either treating the missing values or treating the abnormal data points or correcting for typological errors.
Okay, sir. Thank you.
Okay. Now, let's understand now what kind of typical analysis is usually done in the industry, right? So all the analysis or all the analytics project that happens in the industry can be categorized into one of the three types. Either they're descriptive, or they're predictive, or they're prescriptive, right? Let me explain what each of these are. Now, there are three kinds of projects: descriptive, predictive, prescriptive, right? Let's start with descriptive first. So descriptive, let's use an analogy, right? Let's say you go to a doctor and just give me a second. Yeah, let's say you go to a doctor and that doctor temperature is describing your current status. Yes or no? That temperature, your height, your weight, your blood pressure are every metric that describes your current health condition. Yes. So descriptive analytics is very similar. Descriptive analytics is all those analysis which describe the data, right? If you describe the data using any analysis, you are doing descriptive analytics. For example, you calculate average age of customer coming into your store. It's descriptive. You just describe the data, right? Another example is you calculate the average spend that a customer does in a particular segment, right? Say, for example, what is the average spend that happens in the apparel segment? It's descriptive, right? You're just describing the existing data. Third is, what is the average spend that a customer does in your store? Descriptive data, right? How many miles do you walk every day? Descriptive, right? So these are all descriptive data example, descriptive analytics example, right? Any analysis that you do to describe the data is descriptive analytics. Now, what is predictive? Predictive, again, let's use the analogy. Let's say the doctor tells you to undergo a couple of tests, right? And let's say you underwent some sort of test, and basis those test results, the doctor predicts that you have a particular ailment. Can happen, right? So yeah, so basis these test results, the doctor will predict that you have a particular ailment, right? So you understand that even, say, for example, even if a test shows that you have a particular disease, it might mean that you don't have it. You know, test results are always probabilistic, right? You understand, right? If your test shows that you have dengue, there's a high probability that you have it, but there is also a probability that you don't have it, but still you tested positive, right? But the doctor using those test results will predict that you have dengue, right? So anything or any analysis where you are predicting something which has not happened, or you are guessing that something will happen, is known as predictive. Example, let's say you are predicting who are the customers who are interested in a particular product. Let's say you want to predict who are the customers who are going to default on a particular credit card. Let's say you want to predict which customer is going to churn. Churn means that customer will stop coming to your business, right? Let's say you want to predict how much sales is going to happen next month in your store, right? In all of these cases, there is a guessing, or there is a forecasting or predicting that you are doing, right? So all of this will be predictive analytics, right? So descriptive is describing the data, predictive is predicting something which will happen in future, The third type is known as prescriptive. Prescriptive is all about optimization, right? Say for example, you want to go from point A to point B. There are 4 or 5 different ways that you go from point A to point B. Let's say you want to go from here to the next metro station. There are a number of routes that you can take. Now, usually you will try to take that route which takes the least amount of time, right? How do you find that route which takes the least amount of time? The analytics that you use is known as prescriptive analytics. You are optimizing the amount of time that is required, right? Or for example, let's say I want to optimize the amount of cash that should be stored in an ATM, right? Now, when I store a cash, when I store some cash in the ATM, there is a cost involved, right? I have to send somebody to actually go to that ATM and store that cash there, right? How do you optimize that cost so that your ATM never runs out of cash, right? So that is known as prescriptive analytics. You are optimizing with respect to a particular criteria. Clear?
So it is like hypothesis, sir, prescriptive?
It's not like hypothesis. Prescriptive is optimization.
Okay.
On the basis of the previous data.
Obviously, on the basis of previous data. Everything is on basis of previous data.
So basically, all this predictive and prescriptive modeling is based on descriptive modeling. Let me say.
Not really, but descriptive analytics is usually the first thing that you do, and then basis that you decide whether you want to do predictive or prescriptive. Because until and unless you describe the data, you don't know what is there, right?
So these two terms are quite confusing, like in both of in predictive and prescriptive, we are using past data to predict something or
Not
to
predict.
optimize something.
Yes.
Right?
So there is a difference between prediction and optimization, right? When you predict something, that is predictive. When you optimize something, it is prescriptive.
Prediction only one can optimize.
Not really. So for example, let's say you want to go from here to the next metro station. What is the prediction in there?
Based on the past data. I will use Google obviously, but
Google
based on
uses
the past
prescriptive
data,
analytics.
Based on the past data, Google will tell me that on this particular time interval, this is the traffic amount, this is the cost incurred in this and all.
Right.
So obviously that would be, so for today as well, this will happen. So based on the past data, Google will predict कि आज भी ऐसा ही होगा क्योंकि पिछले इतने टाइम से ऐसा हो रहा है.
नहीं, उसको प्रेडिक्टिव नहीं बोलते हैं, वो उसको assumption बोलते हैं. You assume कि what has happened. See, the basic of or the basis of any analysis is you assume that history will repeat itself. If history does not repeat itself, no analysis will work. Okay, so that is the underlying assumption in all of these three. Say for example, if history does not repeat itself, every fresh day there is a new thing that is happening. What is the use of descriptive? There is no use of understanding the data, right? If history does not repeat itself, there is no predictive. The machine doesn't, if the machine, you cannot predict because every time there is new things happening, right? Similarly, if the history does not repeat itself, you cannot optimize. But that does not mean that predictive and prescriptive are same. The underlying assumption is history will repeat itself. For predictive, you are just predicting what will happen. For prescriptive, you have a particular metric that you are trying to optimize. Either your time or your money or the effort, all of these are to be optimized. Say for example, when you book a cab using Uber or Ola, right? How is the cab allocated? The cab is allocated in such a way such that the driver has to travel the least to reach you. And also you also don't spend time waiting. The second case is if you are using Ola or Uber share, How is the share? All of you know there's a share thing, right? How is the share? How are you allocated to a particular cab? You are allocated to a particular cab such that the driver does not have to take a lot of detours in order to reach your place, right? So there is an optimization involved. All of these are prescriptive analytics. Predictive is what, say for example, predictive is I want to predict whether you are going to use Ola or Uber today. That is predictive. I want to predict whether you want to go to your home or a movie today. That is predictive. I'm not optimizing anything, right? I'm just predicting.
So did our predictions will be affect our prescriptives?
Sorry?
Did our predictions affect our prescriptives?
Did our prediction affect what?
Predictives.
Does our prediction affect prescriptive?
Yes, sir.
Not really. I mean, these are two disjoint things, right? They are not related.
Okay, sir.
Okay, so you are clear on this, right? Okay, if you are clear, give me one example of each. Apart from the examples which I already gave.
So prediction is weather forecasting.
Prediction is weather forecasting, yes.
Prescriptive is if a doctor is prescribing
Don't give that doctor analogy.
So prescriptive is when we go for Google Map, when we...
I already gave that, right?
Yeah, but I'm explaining that further because people are not clear with Google Map as well.
Okay.
Because when I'm picking my metro station, I'm choose one route for the metro station. In between, in the route as well, map is suggesting some other routes. The other route is slower than this route. So the optimization is keep going. So that is based on live data, and that is prescriptive. The optimization is keep going by Google Maps.
Right. Now, what is another example of prescriptive?
Making a trade-off between various factors or objectives that you have. Like
For
some
example?
companies, let's say suppose some companies it may be cost, like if you're making a car,
Right.
the cost of material
Right.
versus how much output you
Right.
Right. There can be two factors or there
Right.
can be multiple factors.
Right.
Depending on that and maintaining a trade-off, you will have to
Correct. You understand what example she gave? Say, for example, you are manufacturing a car, right? From the manufacturer's perspective, why does not everybody manufacture a Ferrari? Because they need to use a trade-off, right? Based on how much money you spend versus how much price you can quote versus how much is the customer willing to pay. So there is an optimization involved here. What features do you put in a particular car, right? So that's prescriptive analytics. You're optimizing your effort, keeping in mind the customer demand.
Stock prices can be prescriptive.
Stock prices, only prices will be predictive, right? You will predict whether the stock market will go up or down. But you've heard about algorithmic trading. Yes. Algorithmic trading is prescriptive, right? You trade in such a way that your money at the end of the day is optimized or maximized. Like algorithmic mutual fund. Yes.
Different criteria.
Right.
So can you once again explain how predictive and prescriptive are disjointed? Because as per my understanding, predictive is something which will happen in future.
Yes.
So if we recommend my business partner, my client, I will recommend take the path A. There are three paths for you: path A, path B, and path C in predictive analysis. So if the optimization has to come as like another one was saying that we have to optimize a certain metric in the prescriptive analytics. So naturally the trade-off between path A, path B, and path C will be different. So eventually it will come to client that he wanted to choose from A or D, and we will choose suppose D, and we will do all the optimization as in terms of cost, as in terms of features, in the example of Ferrari car. So eventually they are becoming jointed They're converging at one or another point. So how they are disjointed?
Okay. Predictive is basically, so for example, if you talk about path A, B, C, and D, predictive will tell you what is the probability that a person will take path A. Prescriptive will tell you whether you should take path A or path B or path C or path D if you want to minimize a particular quantity.
Yeah, that's what I'm saying. They're
different, right? One is talking about which one you will take.
Okay.
One is talking about which one you should take. Okay, that's the difference.
So Google Map is the predictive and the prescriptive both having. Google Map is the example for the predictive and the prescriptives.
Sir, I don't know. I don't work for Google, right? I don't exactly know what algorithm they use, but apparently it looks like some sort of prescriptive analytics.
When the time we are searching that predictions it is giving where this route is having an such type of the 8 minutes and the 10 minutes traffic.
Yes, but that's not predictive, right? That's real-time data. It's not predicting.
Okay. Okay, sir.
Sir, I wanted to just verify. I've written 3 kinds of analysis for these. So yeah.
You have written what?
The examples for all the 3 types of analysis. I just want to validate through you.
Yeah.
Yeah. So like descriptive is like how many flights like depart out of Delhi airport every day. This kind of descriptive.
Can you speak a bit louder?
Yeah. Like how many number of flights depart out of Delhi airport every day? That can be example of descriptive.
Yes.
Okay, so predictive, it can be like what will be the number of flights which will be departing tomorrow out of Delhi airport?
Right.
And prescriptive can be like how many number of flights should depart every day out of Delhi airport so as to minimize the delay in departures.
Right. Right.
So it depends on the type of question that we are asking.
Exactly.
The analysis depends on the kind of question.
Correct. Correct.
Thank you.
Okay, the suggestion that you get on your Facebook profile, what kind of analysis is that? Huh? Prescriptive. Okay, what are you optimizing there?
We are optimizing the parameters that he is going to buy or not.
Oh, what is optimizing there? What are you exactly optimizing?
Whether that person is going to buy that product or not based upon his searches.
So you are predicting, right? Whether that person is going to buy or not. Predictive analytics. So most of the marketing campaigns that you see are all predictive analytics. Okay. Any other question on this? Yes.
For prescriptive, it's mostly on the business and
Yes.
like I'm a business person and
Yes.
I want to do certain marketing campaign.
Right.
So it's like I'll think about like whether giving an advertisement on Facebook is beneficial.
Right.
But for user, it's saying it.
Yes. Prescriptive is more close to the business because here you are actually optimizing the business metric, right? Whereas predictive and descriptive, these are also business driven, but I mean, in a predictive case, business is not as much involved as in a prescriptive.
Predictive modeling is basically based on the users. It's basically based on the user part.
Yes, it depends on what the user does. Yes. Okay. Now, so these are the different types of data analysis that you will do. Now, in a particular analytics project, do we only do descriptive or predictive or prescriptive? No. It depends, right? If your question asks you to do descriptive as well as predictive, you will do both. If your question asks you to do all the 3, you will do all the 3, right? It depends on what is the scope of the business question, right? Depending upon the scope of the question, you might use one or more of these types of analysis. Clear? Okay. Cool. Now, the next thing that we are going to do is we will talk about what are the tools that we are going to use for this particular course, right? And what are the tools available in the market? The tools that are available typically in the market, don't go by this. This is not the exact representation, but I'll tell you the tools available. The tools available in the market are typically four. One is called SAS. SAS stands for Statistical and Analytical Software. Then you have a language called R. Then you have SPSS. And then you have Python. Now, apart from that, there are other languages as well, which are not as popular as these. For this particular course, we will be using Python, right? Now, let's understand why. We will not use SPSS because SPSS has almost become obsolete and very less companies nowadays use SPSS.
What is the full form?
SPSS has no full form.
Okay, that's
Yes. At least I don't know. I mean, you can search about it, right?
Statistical package for social sciences.
Okay. What package?
Statistical package.
Statistical package for social sciences. Okay. Yeah. Now you are basically left with three choices here, right? Either you use SAS or R or Python, right? All of these three languages have their own advantages and disadvantages, right? Say for example, SAS. What is the advantage of SAS? One is it is fast. SAS is really, really fast. Second advantage is algorithms are optimized and guaranteed. Algorithms are all optimized and guaranteed for, right? The SAS as an organization guarantees that the algorithms will give you an accurate result, right? So these are the advantages. Now, what is the disadvantages? Disadvantage is cost. SAS comes around a typical SAS modeling software, which is called SAS EM. SAS EM comes around 70 lakhs for a single license source, right? So you see that there are very few companies who can afford it, right? So SAS typically has been reduced to two or more sectors, banking and retail. Because for example, in banking, people don't care about the money, right? 70 lakhs is pocket change for banks. So they still go for SAS because for them, speed and accuracy is more important. Okay. And retail as in big ticket retails like Walmart, Target, for them also money doesn't matter, right? So they also go for SAS. The next option is R. Now, what is the advantage? The advantage of R is it's free. Second advantage is it is designed for statisticians. This R is designed for people who come with a statistical background. This is a language which is designed for statisticians by statisticians, right? So this can be a disadvantage as well if you are not coming from a statistical background. But if you are from a statistical or a mathematical background, this will come really easy to you, right? Now, what are the disadvantages? Disadvantages, it is slow. Okay, and the reason it is slow is R will load the whole data in your RAM and it will keep all the runtime processes in your RAM. So for example, if you have 8 GB of RAM and you have 16 GB of data, you can't process using R. Okay. Now, what are the other disadvantages? Other disadvantages, the algorithms are designed by random people. I mean, not random. These are people who have some sort of statistical background, hopefully. But any Tom, Dick and Harry can design their own package, right? You one fine morning can design your own package and upload it for others to use, right? Nobody verifies or take guarantee for any algorithm that is there in R. Okay, so these are the disadvantages. But I mean, having said that, R is gaining a lot of popularity because it's free and designed for statisticians. So a lot of people use it, right? Because I mean, if you look at the R platform and the language, it's very easy to capture or learn. Now let's come to Python, right? Python, what is the advantage? Again, it's free, right? Second advantage is it is designed for anybody. Anybody can learn this. You don't need to have any particular background in any kind of mathematics or statistics to learn this. Third advantage is algorithms are designed only by reputed developers. I mean, in Python, nobody, no Tom, Dick and Harry can submit their own package. You need to be verified by the Python community in order to actually contribute a package to the Python list, right? So it's not guaranteed by anybody, but still it's better than that what is happening in R, right? What is the disadvantage? Disadvantage is, again, it's a bit slower as compared to SAS. It's much faster than R, but it's still slow. If you are dealing with large amounts of data, and if you are running R or Python desktop version, it will be slow, right? Say for example, if you are running with like 1 GB of data on a 16 GB RAM card, it takes around a minute for you to get any kind of response. It's slow, right? But the advantages are far more than the disadvantages, right? So that's why the choice of language for this particular course is Python, right? Now, apart from these three evident advantages, the fourth advantage is if you want to move on to deep learning, Python is compatible with deep learning frameworks. Say if you want to move into advanced machine learning and deep learning, most of the frameworks that are there for deep learning are actually compatible with Python. For example, TensorFlow, Theano, Keras, all of these are actually compatible with Python. Okay, so that's why Python is the tool of our choice. Now, are you clear on why we chose Python? Okay. Now, if you are clear on our choice, the next thing that we are going to discuss is what version, right? Typically, we will recommend Python 2.7, right? The reason being, most of the analytics packages, they are yet not stable with Python 3, right? So I would recommend use Python 2.7. But if you don't want to use Python 2.7, go ahead with Python 3. Doesn't matter. I will use Python 3. If you want to use Python 3, use Python 3. But typically, people in analytics are using 2.7. Right? There is basically virtually no difference. Virtually, there are no difference between these two versions. Okay. Yes, but for this particular course, you will not encounter those packages.
Sir,
Okay.
Sir, I heard that for web development, Python is more easier to work. So
Sorry?
For the web development and all, means we can easily connect with the website and all.
Sir, I'm not going to go to web development now. So this is about data science.
No, I just want to know, sir. That is.
I have no idea about web development.
Okay.
I've never worked in web development.
Okay.
Okay. So all of you are clear on which version to use? Yeah. Okay. Cool. Now let's talk about which platform or which development environment are we going to use. All of you are going to download a framework known as Anaconda. Right? Python, Anaconda. See?
What about P?
Yeah? We'll come to that. Okay. All of you will download Anaconda. Right? Now, how do you download Anaconda? There will be a link somewhere in this document. You will get this document. There will be a link somewhere here.
I'm audible. Hello.
Yes.
Yeah, you mentioned Python is slow. Can you explain why it is slow? I just missed that part. Can you please repeat that one?
I did not say it's slow. I said it's slower than SAS.
Slower than SAS. Okay.
Okay. I mean, you can go to installing on Windows. It's very, very self-evident. Right? All of you have, at some point, I'm sure, have installed some software from the internet, right? It's very self-evident. Just keep on clicking.
Okay. By the way,
at some point, it will ask which Python version to use. You can pick and choose between anything, right? Again, recommended is 2.7. You can also go for 3.7.
Can you share the link of this?
It's there in the PDF. The one that I'm referring to. I will email that PDF.
Python is also processing all the data on RAM only? Python is slower because it is also processing the data on RAM?
All the languages process data in the RAM only. There is no language which can process data in your ROM. But the way you organize those data is different, right? R will load the whole data in the RAM and process. Python loads bits and pieces of data. So that's why it's faster. It's faster than R, but slower than SAS.
Okay.
So SAS is faster because it's run on the virtual machine?
Not really. I mean, you can also run SAS in your local desktop. SAS is faster because the algorithms are more optimized.
Okay.
Okay, but that is a licensed one, is it? It's not open source?
It's not free.
Okay.
Yeah. Okay, so you have to click on the link and install Anaconda, right? Once you have installed Anaconda, the next thing that you need to do is, if you search Anaconda in your start button, you will see this Anaconda prompt. Okay. Click on this Anaconda prompt, you will see a black screen like this. Okay. Now in that black screen, what you need to do is write Jupyter Notebook. And press enter. Okay. Once you press enter, it takes a couple of seconds to open up a page which will look something like this. Okay. Once you have come to this page, the only thing that you need to do is there will be a new option here. Click on new. You will see there will be an option of Python 3 or Python 2.7 depending upon what you have installed. Right? Click here. It will open a new page. Right? Now in this page, what you need to do is write something like this. And then press Shift Enter. If you get the right answer, it means Python has been installed. Clear? All of you clear on what you have to do? Okay. Please ensure that before you come to the class next day, you have done this. So that all of you have Anaconda and Python running and appearing in your system. Yes, you need to write this. You can't see. Jupyter, Jupyter, Jupyter Notebook, space notebook.
Once you will open the Anaconda dashboard, also put it.
I would recommend it doing this way because this is faster. Okay. We'll talk about that later. All of you are clear on this? Okay. Now.
Those person who has a very small RAM space, they can also use Miniconda. Is there any difference?
Sorry?
Difference in Miniconda and Anaconda?
I have no idea, man. I have never used Miniconda. I have never faced the problem of less RAM because my system is around 4 GB of RAM. Anaconda still runs fine. Okay. Okay. Now let me open the Anaconda Navigator and let me explain a couple of things. It takes a bit of time. By that, before it opens, any questions? No question. So let's wait for this to open. It takes a lot of time.
Anaconda includes all the packages we need.
Yes, I was coming to that. So Anaconda, once you have downloaded Anaconda, for this course, you will not need to download any package. Anaconda comes with around, I think, 10,000 plus packages already built in, right? So for this particular course, you will not need any other package. Okay. Any other question? Yeah. Okay, now Anaconda is a distribution framework. Distribution framework basically, I mean, in a layman language, it means it gives you a multiple ways to program in multiple languages, right? Primarily in data science, people either use Jupyter Notebook or they use something known as Spider. There is no difference in terms of the code. The only thing that is different in Python and Jupyter Notebook is, in Jupyter Notebook and Spider is, Jupyter Notebook is more suited for data analysis because you see, you get the output just below the code. This is known as inline programming, right? You get the output just below the code, which is beneficial if you are analyzing the data. Because ideally you would like to write a code, see the output, and then decide what to do next. Spider is mostly used for batch programming, where you want to write 10-15 lines of code which can do a particular thing, right? So that's the difference between Jupyter Notebook and Spider. And since Jupyter Notebook is more suited for analytics, we will use Jupyter Notebook. Okay.
So both are offline, both are working offline.
Everything is working offline. You don't need internet connection to use this. To install packages you will need, but to use Python you don't need internet. Is anything else? Nothing? Okay, cool. So that's about it. I mean, I had only these things to cover today. Hopefully you are interested enough to come next day. Yes, okay. Otherwise you have paid for it, so you will anyways come, right? Okay, so I will see you next day. So I'll close the session for the day if you don't have any questions.
Hello.
Yes.
To run the Jupyter Notebook, first I have to install Anaconda.
Sorry?
To use the Jupyter Notebook, I have to use first Anaconda, right,
Yes.
sir?
Yes. Okay. So that's about it. I will close the session for the day. Before you come next day, please make sure